All right, well, thank you very much. Thanks for having me. So my name's Corey Adolphus. I'm a customer engineer at Google, based here in Melbourne. We do actually have an office here in Melbourne, although it's quite small. There's only about 30 of us in the office here, and from a cloud perspective, we've got about, of that 30, that's about 8 people. So we're still very new, but we are growing quite rapidly as well. And we're really excited to finally have a lot more to talk about, because we do actually have a region in country, with Google Cloud's actually been in existence in one way, shape or another since 2008. But it hasn't been onshore until June of this year. So that's certainly very exciting for us. What I'm going to talk about today is, as the name would suggest, how Google delivers services at planet scale, right? And how what we've had to overcome from infrastructure, hardware, network, software, services, and so forth, and management and orchestration and all of that sort of stuff, to be able to deliver services at this kind of scale. And really that leads right into a bit of a history of containers, and containers specifically at Google. So this is the iconic page. And in fact, I don't know how many people really see this much anymore, because I don't know about you, but I just go straight to the address bar and start searching now. But the good old google.com homepage, that started back in 1998. Larry and Sergey, in their dorm room at university, cooked up this idea of a hypertext indexing engine, search engine, and to do it in a different way. The original technology, which has obviously been improved upon over the years, was called PageRank, and it quickly became a solution that people went to instead of some of the more common ones at the time, because it seemed to surface up more relevant results for people. But it really had some quite humble beginnings, and I'm not sure how well that's kind of visible from the back there, but that was the team back in fact 96, but it wasn't sort of commercially available, if you like, or on the web until 98. That was the team there from from the original team at Stanford. They had basically, like in a dorm room, like a lot of Silicon Valley startups, started in the garage or started in the dorm room. So, that was their equipment. This was their sort of racks of servers when they started going, okay, well, we need to now scale this out and build our own kind of, way of doing things, rather than buying, lots and lots of, beige boxes. They started building this out. So it was, quite humble beginnings, but, that is where they've come from. And even in the paper that they originally published as part of their doctorate at Stanford, was talking about scale. So it was, even from the very beginning, it wasn't just about what was the size of the internet and the amount of pages on the internet back then, but they were thinking, well, this is just going to keep growing. How do we scale our infrastructure and our software, our search engine, to be able to cope with what's going to happen on the internet? And they had a lot of foresight there, and of course, as I said, it's been improved over and over. So what famous movie quote does this conjure up? Anyone? Right. Well, that's where he started, at $1 million, and was laughed at. But then he changed his mind and said $1 billion or $100 billion or something like that. Google has 7 unique properties, or web properties, or services that we provide that have 1 billion users each, active users, right? Whether that's, of course, search, Gmail, Android device activations, the Play Store, Maps, Chrome browser and Chrome OS, and of course YouTube. There's something like 720 hours of video uploaded to YouTube every minute. Insane. Most of them are cat videos, I think. And the most recent property to reach 1 billion users is Google Cloud Platform. Now, we don't have 1 billion customers, but our customers collectively service over 1 billion users, right? Because we have some monster names like Spotify and Snapchat, so keep snapping, right? Pokemon Go, keep chasing those Pokemons, because that's all running on Google Cloud Platform. And we've got a whole ton of services on. I'm going to spend an hour on each of them. No, I'm not. All right. So look, I guess I'm not going to go into Google Cloud Platform in that level of detail. Don't have time today. But the purpose really to talk about all of these services that have so many users is that we've spent the better part of 17, 18 years figuring out what works, figuring out that, okay, virtual machines, they were good for a while, but quickly couldn't scale for the type of services and the scale of services that we were offering. So that's when we started looking at containers, and that was actually back in about 2004, where Google engineers started looking at the basically C groups inside the Linux kernel and LXC as that sort of evolved to way back in 2004, where we started deploying our services in containers. And so we've really been doing this for a long time, to the point that now everything we do is done in a container. Every time you do a search, it's a container spawning up just for you. Every time you open up Google Maps, open up a Gmail message, they're all spawning up in their own container. All right? Around the world, this is what we do with our infrastructure. Even the VMs that you launch on Google Cloud Platform are actually launched in a container construct under the covers. Doesn't matter that in a sense that we do it, the VM still looks like a fully fledged VM to, when you're using it, but under the covers, in order to orchestrate it and scale it and deploy it to the right place with the right, that has the right amount of spare cycles, we use container technology and container scheduling technology to be able to do that. So pop quiz. Who here, not you, Dylan, you've seen this before, come on. No? All right. How many containers does Google launch each week?
10 billion? 2 billion. 2 billion.
Oh, okay, well 2 billion was the correct answer. 10 billion, was, I'm sure we'll be there soon. But all right, I tell you what, I've got some t-shirts here for those that said 2 billion. Maybe come and see me afterwards, right? I'll get a big rush. Everyone said 2 billion, right? Yeah. I don't have that many t-shirts. But good, 2 billion containers a week, right? Now that is massive, 2 billion per week. But why containers? What makes them so useful? Why did Google go down that path as opposed to doing things the way we were, whether it was with VMs or with just individual processes, individual, whatever? Well, we found that they were the right unit of management and density to the hardware and ease of declaring and portability and provisioning. There was a whole bunch of things that we found that we got out of containers way before all of the services that are available to us now. Like you just heard, all of these cloud native services that are coming out to wrap around Kubernetes, which is a wraparound of Docker, which is a wraparound of LXC on Linux, which is a wraparound of C groups. It's, there's so many layers of abstraction, but it's to add functionality. And what we've found is that containers in general just provide that perfect mix of portability, of reusability, being able to go, okay, well, if I take this container and run it over here, it's going to run exactly the same because it's based on exactly the same definition. There's no having to take a full snapshot of a running image, which then when you launch it might have some dependencies. There was a whole bunch of things, and of course the speed at which you can boot up a container versus a virtual machine was what we had to do to be able to get to, again, the scale of the amount, the billions of search queries that we get every day. But there is a problem of having too many containers, right? Well, maybe. If you've got one or two, Docker run container, whatever, right? Easy. But once you have dozens to hundreds to thousands or billions, as we have, absolutely impossible if you don't have a container orchestration solution. So you're all here because you're a part of the Kubernetes meetup. This is all kind of preaching to the converted here. Clearly, Kubernetes has come about because there was a need to be able to manage containers at scale. Now, where did this all actually come from? You know, managing these deployments, managing the monitoring of these containers. Where are they? Do I update them or do I destroy them and re-provision them, right? Scaling, how do I do load balancing and so forth. So Google actually invented a technology, again, because we've been doing this since about 2004, which we called Borg internally. You know, there's a bit of a homage there to, I think, where that name might have come from. Not that we can acknowledge that formally because I think Paramount Pictures would sue us, but you know, the Borg, simulate and control and coordinate, that's where the term came from, of course, and that was, and still is, Google's internal container orchestration solution. Right, so this is where we declare that we want these containers to exist and where to exist and how many and how, you know, how they should scale and what they should be able to talk to and how someone should be able to talk to them. We declare that in Borg and Borg makes it happen, and it continues to work to make that always be the case until it's no longer what you define as, you know, your expected outcome. And that's how we schedule things. So we schedule a Gmail mail message to be able to be actually opened on someone's browser somewhere. Well, that is a job in Borg. Borg then goes and makes it happen, and then the JavaScript on your client gets the socket and renders the HTML. Right? It's and it all happens in usually under you know, 250 milliseconds. We aim for that. We try and get better and better and better, but and it depends on how far you are from a Google cache. But it's all scheduled using Borg. And so we did that because we needed to, again, abstract away from the run this container here. So that's great. You know, Google has this container management system, great story. You know, how does that apply to people in the real world? That's where Kubernetes came from. So we actually open sourced Borg as it was in 2014 and named it Kubernetes and basically put it in the Cloud Native Computing Foundation to incubate it, which is a similar kind of incubation, open source incubation hub like, say, the Apache Foundation that does other, you know, other products. So I don't know why, but we chose the Cloud Native Computing Foundation, maybe because it's cloud native, just a, you know, wild guess. So we called it Kubernetes. Kubernetes, it's the Greek word for helmsman, and is also like the root of other words in English like governor, cybernetic. So there's, you know, a couple of little tie-ins there as you see from the Borg days. And this is now what we're pouring all of our focus into. And so we are the #1 contributor to Kubernetes on GitHub, you know, through the Cloud Native Computing Foundation, but we are by no means the only organization that is steering the direction, so to speak, of Kubernetes. Yeah, all of the tech heavyweights have piled onto this as well. So AWS have, Microsoft, IBM, Uber, and you name it, a whole bunch of companies have, you know, commercial organizations are basically putting their weight behind Kubernetes and are contributing to this open source project. It is 100% open source. As you heard before, there are many flavors or distributions of them, and thankfully now with this new certification process that has been launched, you can go to the kubernetes.io page and have a look to see, okay, well, or the Cloud Native Computing Foundation page, and have a look to see, well, what are the, if you like, certified, bona fide Kubernetes distributions out there that you can be absolutely guaranteed that if you take any of your YAML definition files that you would deploy on Cloud A or on-premise infrastructure A running Kubernetes and put it over here, that as long as you picked the source and destination are certified Kubernetes distributions, then that is part of the guarantee that you will have lift and shift kind of capability, drag and drop, so to speak. The software itself is written in Go. Some would argue the one true language. I'm not quite so religious about it, but apparently it's good. So another pop quiz, another t-shirt option here. Why does the ship's wheel on Kubernetes have 7 handles? Go on.
7 of 9.
Oh, there you go. You got it. You got a t-shirt. Who remembers this? Surely there's a lot of people in this room that know 7 of 9 from Star Trek. So, you know, the 7 handles on the wheel. are a direct reference to Seven of Nine, which was her name. She was the more friendly Borg. Right? The others were basically trying to kill us all. So Kubernetes runs in many environments, on your laptop, on a bare metal piece of server without any other operating system. You can just sort of boot up Linux and then get Kubernetes going. You can, of course, run it inside a VM. You can run it on AWS. You can run it on Google Cloud Platform. You can run it, there's other distributions out there like OpenShift from Red Hat. And I'm not going to list them all clearly because there's hundreds, but you can run it in a variety of places. So it's very, very widespread. And as I said, it's 100% open source. The API with this certification now means that you have that guarantee portability in lift and shift. And it's very modular, which I'm sure again you all know. But I mean, again, so what is it that Kubernetes does that is so good, and why is this becoming the kind of the force du jour for container orchestration? Just does things well, I think, is probably the short answer. So much so that there's been some other container orchestration projects out there. Docker Swarm, Apache Mesos, and again, great technologies, but I don't know, it seems that, Kubernetes, by its inception, it was decided, and it was, of course, by Google, who, this is how we do things internally, did things and do things still, is you declare how you want something to be, and then Kubernetes will continue to check the system to make sure that it is what you've declared in your definition or whatever you run on the console. So if you say, I want my service to have this particular web server pod to have 3 replicas, and that needs to be able to be accessed through the load balancer, HTTPS, and that's my definition, Kubernetes make it so, it will then go and deploy that. It'll make sure that there's those 3 replicas, and if the hardware, let's say, or the operating system underpinning one of those pods dies, then Kubernetes will detect that and go, well, now we're out of sync with what you've said that you want, what you've declared, so it will then make it so again, so to speak, another Star Trek reference, by going and deploying it on another node that is healthy. Right? So that declarative approach means that you don't have to code everything that you're trying to do implicitly. It's rather declare how you want it, and then the details are just managed for you by Kubernetes. So you can now focus on the fun stuff, right? Just having your code running, whatever it is, servicing your customers, and not having to worry and manage the underlying infrastructure. And so much so, as you heard before, and a couple of weeks ago, I think it's been now, that Docker announced native support for Kubernetes. So, for a while there was a bit of pushback, shall we say, but it's now a first-party supported interface in the upstream Docker code, which is fantastic. So that, I think, kind of speaks volumes that, this is probably going to be the container orchestration system that you're looking for. So let's have a look at this a bit closer. And again, I'm just sort of conscious that you guys are here, you're part of the Kubernetes meetup. I presume you know a lot of this stuff, but I'll go through it a little bit anyway, just, because I did say that I would, right? So the Kubernetes, which is a word that I made up, and you can use that under license, is basically what I'm trying to talk about here is what are the fundamentals of Kubernetes. And it starts with the master. The master is, as the name would suggest, the thing that controls the whole cluster, right? So you've got a cluster, and inside the cluster, the main brain of everything is the master. It's where, when you connect via any kind of user interface, whether it's the command line or any kind of graphical user interface or any kind of API from other tools, it's actually talking to the master, right? It doesn't talk, none of these external things talk directly to the worker nodes. Only the master talks to the worker nodes. And in fact, so much so that there's definitely a strong recommendation or best practice that you should never interact with the actual worker nodes. You should never SSH to those nodes. You should never, ever SSH into a running container. There should be enough tooling and information that you can get out of Kubernetes through the API or through the command line, that, such as getting logs and getting the dump of the console, so to speak, of the containers, that you don't need to actually go in to see what's going on, right? If for whatever reason you have to go in because there is no other way, then there's something not quite right about how that container has been built. It should be piping all of its information out, to stand it out, and that can be collected directly by Kubernetes. The logging, you should be logging to Fluentd or something like that, because then that can then be sent out of the container cluster, the Kubernetes cluster, to a centralized logging solution. Right? You should never connect to any of these. That's kind of like just a strong best practice. That's part of it. But these nodes are what actually runs your containers. Right? So the master goes, when you define this, you say how many worker nodes do I want to have, and if you're doing this all yourself manually, then you'll need to say, and this is a worker node, install the kubelet process on there, and then that will then connect back to the master, and it becomes part of the Borg, part of the Kubernetes cluster, right? And then when you define things like deploy this web server pod, make 3 copies of it, the master then goes and makes sure, okay, well, what are my healthy nodes out there that have enough resources? Go and make that happen. Go and run that container. And it's the node and this the Docker runtime that's running on this node will pull the image from the image registry that you've specified in that image comes from, or that container comes from. I know that's a lot of detail that I've just gone through there, but I guess I just want to do a little bit of a level set there as to how Kubernetes and the clustering technology works. So I've talked about a pod. A pod is, if you like, the primary unit of Kubernetes for running containers. You can just do one-to-one, so a pod can have a single container, and that keeps things easy. But if you had containers that should always scale together, so an example of that could be, say, an Nginx web server with a Redis cache or a mem cache, and you should run them as separate containers, but put those two in the same pod. Ideally, again, I'm talking best practices here. It's not, the only way to do things, because then when you define, I want to make sure I've got, 3 replicas, it will actually replicate the whole pod and all of the containers within it. So it doesn't make sense to have things in there like databases. You don't want to have multiple masters being spun up, right? But for things that are stateless and should be together because they interact with each other always and should be scaled together, then put them together. So a caching layer is a good example of that. And then everything in Kubernetes is represented as an object, and you can label them, right? So it's this labels here. So you can have a label here that might say production, and then another label that might be test or staging, right? And then the services, which is how outside end users or whoever needs to consume what is inside these pods. So that could be, if this is a web server, an Nginx server serving up web pages, then this could be a HTTPS load balancer, right? That is defined by this service. Well, it needs to know which pods to serve that traffic to. So this one, it goes, okay, well, I'm looking for the label stage as an example. And so it'll then direct traffic to that particular endpoint to the pods, wherever they are in your cluster, because of that label. And if that node dies and Kubernetes then spins that same that same pod is then brought up on another healthy node, the service and the endpoint to the end user doesn't change. So it's the same IP and all of that. It manages the routing to the new location inside your cluster that pod is running. So the pods are ephemeral, can go away and come back as a new instantiation and somewhere else in your cluster, and that could be in a cloud environment, that could be across multiple data centers, and it doesn't matter. So again, just makes things easier, and there's some of the things that are built in to Kubernetes. But that still looks like a lot of work to set this up, right? I don't know about you, but it does to me. And that's where managed Kubernetes environments come to be. So Google, of course, we have a managed Kubernetes environment, which we call, as of this week, Google Kubernetes Engine. It was actually called Google Container Engine, but as we were certified as part of this Kubernetes certification that we just spoke about, we are allowed to use the Kubernetes name in our product name because it's certified. So we rebranded our managed container engine service to Google Kubernetes Engine. right? So I've updated the slides a couple of days ago as a result of that. It is 100% Kubernetes API compliant, and it is certified, right? So you can do things on Container Engine, and if we're just playing around and you're done with it, you want to move somewhere else because for whatever reason, somewhere else is better or cheaper or whatever, then you can. You can just take everything that you've done and drop it on your other new location that you want to run Kubernetes, and it just will work because that is how it has been designed, right? So it is very much 100% compliant, and that's what we mean by no vendor lock-in. It is Kubernetes. We're just managing it for you and providing the compute resources and network resources for it. So this is a little bit of an eye chart, but I guess what I tried to sort of change how I diagram this to illustrate what I'm trying to come across. So if you were hand installing Kubernetes, you got to do a lot of work. You got to build up the master server, make sure all of the services are running. You got to set up your network to make sure that the services can actually talk to each other on the right isolated private network. Then you've got to hand curate, if you like, all of the worker nodes. And then, when you make sure that it's all running and then run up your services, it's just a whole bunch of work. Or you could just use Kubernetes Engine and it does all of that for you, so that all you have to do is just say, run this container like this, and then it'll just happen. And it's one command to have that cluster up and running, ready to service production workload. One command. It takes about 5 minutes for it to spin up because it does a lot of work. We do all the work for you. But once it's running, we can make sure that it remains up to date. So the master, we always make sure is running at the latest stable release, and you don't have to touch it, we just do it. You can opt out of that, but by default, we automatically upgrade the master. And then you can also opt in for automatic upgrades of the worker nodes to newer versions of Kubernetes. So it just takes away what is a lot of manual work. Security is a big thing, right? You want to make sure that anytime there's a vulnerability found, it's fixed in the upstream code. You just want it to have it happen for you so that you can just focus on the services that you're delivering. And that's what we do. So that was a long sort of description, if you like, of the history of containers at Google and how Kubernetes came to be and how Kubernetes works. What I've got for you here, and if you can all just pray to the demo gods or whoever, because I do have a live demo to show you about a continuous delivery pipeline using, obviously, Kubernetes running on Google Cloud, so Kubernetes Engine, but being driven by Spinnaker, which is another open source tool set that's nicely integrated with Kubernetes to be able to take source code. I'll just make a minor edit to a file that serves up a web page and check that into, or push that back into GitHub. Then I'll show you how that triggers a build of a new container. And then once that container is that new build is registered in Google's container registry, Spinnaker will detect that and it will pull that in and deploy that container to a staging Kubernetes cluster. And then it will ask me to confirm that it's all working well. So a manual kind of judgment, and then it will go on to deploy that same container into the production environment. So it's showing you basically a continuous delivery workflow, all pretty much in a cloud native landscape. Let me bring that up. All right, so this is the web interface to Google Cloud Platform for those that haven't seen it. And you've got your menu here and all of our services, Kubernetes, compute, and so forth. But I've got some tabs open here. So this is the Kubernetes engine, managed Kubernetes, as I was saying. I've got my cluster called kube-cluster1. It's running in Australia Southeast 1A, so that's Sydney. And I've said that it's a size 3, which means that it spins up 3 worker nodes. And this is the version, so it's bleeding edge. This is the current release of Kubernetes upstream, right, 1.8.3. And what I've got here, if I go to my GitHub repository, is I've just got a repository called GCP Codelab. I've got some files in here, and as you can see, I was testing to make sure this was working, and it wasn't a couple of hours ago, but hopefully it is now. I've got these files here. So this is the code repo. Now just bear with me. I am going to go to the command line. So wish me luck. All right. So I'm in the Cloud Shell. So this is basically built into the GCP console, where you can just click on Open Shell, and it basically tunnels your authentication of how you've authenticated to Google Cloud straight through and pops up a shell that's running as effectively a container inside of GCP that's persistent for your user. So it's got a 5 gig home directory, and it stores all, it's just really easy. So I don't have to stuff around with PuTTY on Windows or something on macOS or whatever. It's just all natively there in the cloud. And I'll just edit my main.go file, because I've cloned this GitHub repo. All right, so what I'll do is, let's change this. Meetup for the win. All right. Save that. Meetup. Push. Origin. Release. Now, before I hit that, I'll show you something here. So inside Google Cloud platform, we have container registry. So this is just another managed service that we have. And what you can do is you can set up build triggers. And those triggers can be from a remote source like GitHub. So it doesn't have to be something running inside GCP. So I've set up a trigger to watch my GitHub account for any pushes into that repo to the release branch. All right, so I've got a trigger already set up inside GCP to be watching my GitHub repo. So I'll go back here and I'll just push that as a new release with a new commit. All right, so that's written it there. If I go to GitHub, refresh that, you'll see the main.go, there it is, meetup, that was the commit label that I just gave it. And then if we go to container registry, build history, we'll see that this has triggered, because it's detected that, here we go. So it's building a new instance of that Docker container that I've defined. So that's finished, and it's created this image. Oh, sorry, that was the build, but the build ID is this, and then the image ID is, it ends in EBCD. Hopefully that's visible to everyone there. But if I go here to images, I should be able to see the latest image in my folder here. EBCD, yeah. So that's the latest image. Now, if I switch to Spinnaker, as I was describing before, Spinnaker, I've got some pipelines set up in Spinnaker, which again is open source software. This is just running on a compute instance inside of Google Cloud. And if I just clear my filters and watch for this, just takes a little bit of time sometimes to pick up. Basically, it's polling, and it's just checking if there's a new image in my registry. So this is what I ran an hour ago, but bear with me while this kicks off again, hopefully. Anyone know how to rap or tap dance? No? Because I don't. So.
What did you use to deploy Spinnaker?
For this demo, I deployed Spinnaker using a click-to-deploy function or capability that we have in GCP. So we've got effectively a marketplace, which we call Cloud Launcher. So you go into Cloud Launcher and you type in Spinnaker, and it comes up in the list. I'm just going to refresh that. Please work. Deep breath.
Craig, another question. In the interest of serverless stuff,
Mm-hmm.
has Google got any plans to, rather than defining the compute instances you want underneath your CUDE cluster, that you basically, we don't care about that anymore, and you just charge us the number of seconds we use particular service? Are there any plans for that?
Yeah, look, that's a good question. So just to repeat for everyone, underneath the covers in GCP, what's happening when you declare or when you create this Kubernetes cluster, we're actually going and deploying VMs on our compute engine service in order to have this Kubernetes environment running. And we kind of expose that to you. So if you go into Compute Engine, you'll actually see the instances for that Kubernetes cluster are there, and you can see them as part of your list of instances. See, there's my kube-cluster 1, 2, 3, or the 3 worker nodes. You don't see the master node. That is completely hidden from you, but the worker nodes are seen there. And in terms of from a billing perspective, it actually comes up under compute engine hours is how we bill you right now. So yeah, look, I mean, that's are we going to take it to the point where we just hide all this from you and it just is provided truly as what would appear like a complete serverless environment? Clearly it has to run somewhere, but that is being looked at. And what you'll find, I guess I can't talk too much about roadmap here, but we are doing a lot of work around, because we do have serverless platforms now. We've got App Engine, which is bring your own code, right? So this is bring your Docker container orchestration kind of YAML files and we'll run it up for you. We have App Engine, the App Engine Flex environment where you can just bring your container and we'll manage, you don't have to define ingress points for services and so forth, we'll manage that. And then we have full serverless where you literally just bring your code or your app and deploy the code, and then we'll spin up whatever we need to under the covers, but you get billed on App Engine seconds as opposed to on compute engine instance time. We're looking at how we can bring those things, and we've also got functions as well, right? So where just a function executes, we're looking at how we can bring that together more so that it's one kind of serverless offering that you can still do whichever level you're more interested in, whether it's whether you want to tinker with the underlying bits and pieces or whether you just want to bring your YAML files and it does it for you. That's definitely where we're working towards, but there's just nothing in the immediate short term. So now let's see if this thing is working. I don't think it is. Well, let me try one more time. Go back to the start. Seems to kind of cache things. No, it's not doing it. All right. Well, that's makes for a not a very interesting demo. But in what I ran a couple of hours ago, what it does is it deploys. Firstly, it detects that build, that new image has dropped into the container registry, which in itself was done based on a build trigger from that new push into my GitHub. So it detects that new image in the registry, it pulls it down and then deploys it into a server group, which is a replica set, but it's called a server group or server cluster in Spinnaker, called CodeLab-Stage. That's just what I named it. So if I go to Kubernetes Engine, go to workloads, I can show you that which was deployed before CodeLab-Stage. All right, so it's a replica set in Kubernetes. Go in there and you'll see, okay, well, what are the pods that are in this replica set? And I've only set it to just have one. All right, so there's the pod, and then inside the pod is the container. So there's my previous image there, 8E6A, which was the previous image from, there it is, 8E6A. Right? So it pulls that image in, runs it in its own replica set, and I've defined it in Spinnaker to use the strategy of Highlander, which is basically destroy the old replica set to then, after you've successfully deployed the new one. And that's why back here in workloads, you'll see that for stage, there is only one replica set, right? Whereas for prod, you'll see that I've got a few there. So if I go back to this software that's just not behaving at the moment, but if you have a look in stage, click on load balancer and down to my ingress object here. So that's incredibly small. Let me just make that. So this is the public load balancer endpoint that was created as defined in, I defined it in Spinnaker. Spinnaker then went and said to Kubernetes, go and make a service definition, which then tells Google Cloud Platform to create a HTTP load balancer, because it's just port 80 is what I defined it as, but you can do 443. And it will then automatically route any traffic to that public endpoint to the right pod at that point in time. So at this point in time, in staging, I only have this one pod, because I've chosen that Highlander strategy. So the service just goes straight to that pod, which is V007 at the moment. So then, again, if it was working, my pipeline then goes on to say, okay, well, validate, which is basically just a manual judgment. So it just pops up saying, is that build that's now running in the staging environment, is it good to go? Yes or no? So I go and say yes, and then that kicks off the final stage of the pipeline, which is to deploy to the production, promote to prod. And so then what I do is Spinnaker can then go and detect what was the most recent deployment in the staging environment, pull that same image so that you're guaranteed that the image that you've tested is what you're actually putting into production. Because remember, devs could be creating new images all the time and you don't want to be picking that up. You want to make sure that your pipeline is picking up the one that you've just tested, and Spinnaker makes sure of that. That's built into Spinnaker there. So you can actually go and say, tell me what was the last one that was deployed in stage, take that image and now go deploy it in production. But in production, what I've got as my strategy for rolling out a new release is I've gone with a red-black approach, or blue-green is another way of determining it. And I've said, when you do that, keep the last 3 replica sets just in case, because I can always roll back to them. So if something just goes horribly wrong, so if you're deploying a microservice into production for that could affect a lot of users, and it's something that isn't seen in test but is seen at load in production, you can quickly roll back if you use something like a red-black deployment strategy. So here you can see that these server groups, or as they're called in Spinnaker, or replica sets in Kubernetes, are still there, but they've been disabled by Spinnaker telling Kubernetes, go disable that, send all of the traffic for this production instance to this particular replica set, which is active. So if I go and have a look at the load balancer for production, that's the image from before as well, but that's running off the production IP, which is .100, as opposed to stage. And what I've said is, keep the last 3. So again, it's built into Spinnaker to automatically cycle out the older or the oldest of these replica sets, so that it doesn't just keep them hanging around, right? And there's lots of different strategies that you can put in here for Spinnaker. So it's, when it works, quite neat. Apologies for that. The usual, never work with children, animals, and live demos. So I haven't learnt my lesson. Okay. So what have I talked about here today? Because the pizzas have just rolled in and I'm really conscious of that, is designing for scale. That's what Google has had to do, obviously, for the services that we run for millions and billions of users. And that technology is what is baked into Kubernetes. Now, you might not be at the scale that Google is, and you may never get there, but it doesn't hurt. Even if you're in the order of magnitude of dozens of containers, you take a dozen containers and then you multiply that out with a dev environment, or multiple parallel dev environments, a test environment, staging environment, pre-production, production, you're talking quickly hundreds and possibly thousands of containers. Hand managing that, do not do that. Clearly you're here as the Kubernetes meetup. Kubernetes is the way to go. Even if your individual service that you're trying to run is quite modest and small, it helps you. It helps you with defining something that can then be replicated very easily in any environment that you might want to run in, okay? So it is for all scales, not just for people like Google. All right, focus on the fun part. So we obviously would recommend that you have a close look at Google Kubernetes Engine. I keep calling it Container Engine because that's what it was known as, but Google Kubernetes Engine, because it's managed Kubernetes. So a couple of clicks and you've got yourself a fully baked managed cluster, so you can focus on your application. Focus on the code, focus on the end customer experience, whoever your customer is. Don't worry about the infrastructure, we can handle that. But there are many other providers out there that also do really good jobs of providing fully managed Kubernetes environments. It's not just Google, so it's a great product for that. And look, I would please ask that you come up, ask me any questions that you like. If I don't know the answer, I will endeavour to find out from our team of people that we have back in the office to get you the right answer. So feel free to come and talk to me. And with that, that's it. Thank you.